Welcome to Mann Maker. I am Ranjan Kumar and today we are going to discuss some important and expected question with details explanation of electronics engineer for BL Probationary Engineer, and these all are questions based on the previous year paper and exam pattern for your exam. Okay. So for PDF and more updates you can join our Telegram channel and WhatsApp group. And now for study material you can download this the Mann Maker app from the Play Store. So study material is available there, just go and check and you can take study material for probationary engineer also. Okay, so we'll start. Okay, if for a silicon NPN transistor, the base to emitter voltage is 0.7 volt and the collector to base voltage is 0.2 volt, then the transistor is operating in the which region they are asking. So if you talk about NPN transistor, so in NPN transistor, when biasing happens, so in that it have four kind of region or mode of region, operating region you can say. When junction like emitter base, then collector base, junction will be formed in when both are in forward bias, when they will biasing in both are in the forward bias, then this transistor mode is called saturation region. Saturation region. Okay, when both are in reverse bias, okay, when they are when both are biasing, both junction are biasing in a reverse bias, in that case this mode of region or operating region is called cut up region. Okay, cut up region. When this emitter base is forward bias and collector base is reverse bias, then this operating region is called active region. Okay, active region. Okay, and when this emitter base is reverse bias and collector base is forward bias, then it is called reverse active region. Okay, so you need to remember this table. From this also sometime question they are asking, like when in a transistor, in an NPN transistor, when emitter base is forward bias and collector base is forward bias, then which operating region it is, the mode of operating region they will ask. So that time you need to give answer saturation. Like that they are asking question, and sometime they will ask question, if NPN transistor is in an active mode, then the biasing of emitter base and collector base will be. So you have to give answer forward bias and reverse bias. Like that they will ask question. So you need to prepare like that. Okay. And here they have given like base to emitter. Just a second. So base to emitter they have given VBE, base to emitter junction. Okay, they have given 0.7 volt, and here collector base CB. So collector you have 0.2 volt. Okay, so you can see 0.7 volt is greater than 0.2 volt, right? So this is your VBE junction VE, and this is your CB. Okay, so we can say this is in forward bias and this is low, so this is in reverse bias. So emitter base or base emitter is in forward bias and collector base is in reverse bias, means this condition it is following forward bias and reverse bias. So it is in active region. Okay, normal active mode. Option A is right answer. All right. Sometime in exam they will ask this question also, like application they will ask. Okay, in like transistor is working in saturation mode, then which application it has. So you have to remember application also. All right, so when transistor is operating in a saturation mode, then it will work as a on switch. Okay, then it will work as a on switch. When it will be in cut up region, then it will work as a off switch. Okay, then it will work as a off switch. When it is in active region, then it will act as a or work as a amplifier. When this is in reverse active, then it will work as a attenuation. All right. This table is very important. You have to remember, because in every exam you will get question from this table. All right. So from here, option A is right answer. All right. So the next one is constant voltage source is. So constant voltage is source is constant voltage source is what? Basically, we have element, active element, and passive element. Okay, you can say we have active element and passive element in electronics device. So for active element, power supply, it will what it will do in active element, that supply energy, it will supply energy. Active element are supply energy, and here passive element are absorb, it will absorb energy. All right, passive element are absorb energy. All right, it is used for current control and voltage control application. Active elements are used for current control or voltage control application. Then passive elements are used for store the energy. Okay, store the energy. Then you can say some example are there, like for active region we have battery, we have voltage source, current source. These are the example of active element. Then for passive element we have RLC, resistor, inductor, and capacitor. These are the example. Okay, and here they have asked for voltage source. So voltage source is here. So it is active element. Okay, it is active element. Till now we know it is active element. Now in option they have asked bilateral and unilateral. Okay, so unilateral means what? Unilateral means what? In unilateral means it will allow conduction. It will allow conduction in one direction only. Okay, in one direction only. Unilateral means it will allow conduction in a one direction only, like you can say diode, voltage source, transistor. Okay, and bilateral is just opposite of this, means it will allow conduction in both direction. Okay, in both direction. All right, example you can say same R, L, C. Resistor, inductor, and capacitor are bilateral. So here voltage source is an example of unilateral, and voltage source is an example of active element. So you can say option C is our right answer. Okay, next one. Which of the following theorem can be applied to any network, linear or non-linear or active or passive or time variant or time invariant? All right. So in a network theory, we have some kind of theorems, like we have superposition theorem we have, then we have Thevenin theorem, then we have Norton theorem. Okay, we have maximum power transfer theorem, maximum power transfer theorem, then we have substitution theorem. Okay, substitution theorem, then we have Telegen Telegen's theorem. These are the theorems are there in network theory. So this superposition, Thevenin theorem, Norton theorem, maximum power transfer theorem, these are can be applied only linear network. Okay, only linear network. These are applicable only for linear network. Okay, Substitution theorem is applicable for linear and non-linear. Okay, linear and non-linear. All right. Then television. Television is applicable for all kind of network. All kind of network means it will be applicable for linear, non-linear, active, passive, time variant or time invariant. Any kind of network is there. This is applicable for all the things. So from here, television theorem is our right answer. Okay. Next time, if they will ask like which of the following is applicable only for linear and non-linear, then you have to give answer substitution. So that's why you have to remember each and every point. From anywhere they will ask question. Okay, whatever I am explaining, that you also need to remember. So now the next question is steady state error for unit ramp input and type 1 system is what? So here they have asking about steady state error. So generally in a control system, we have type 0 system, type 1 system, type 2 system. All right. And for that, we have inputs, that is unit step we have, then unit ramp we have, then we have unit parabolic. So these are the input signal. Okay. So here they have asked for ramp input. All right. So whenever input is your unit step and for you input unit step is there, for that type 0 is 1 by 1 plus kp, then type 1 is 0, type 2 is also 0. For ramp input, type 0 is infinite, and for type 1 it is 1 by kb, and this is your 0. For type 2 it is 0. For parabolic, if input is your unit parabolic, for type 0 it is infinite, for type 1 it is infinite, and for type 2 it is 1 by ka. Okay, so this is the table that you also need to remember. Here they have asked for ramp input, so ramp input is this one, and for type 1 system, so type 1 is this one. So answer will be 1 by kb. If they will ask if the system is 0, okay, if the system is 0 and input we have unit step, then what kind of uh, what kind of what system it is, then you have to give answer type 1 and type 2. All right, sometimes they will ask if in a type 1 a steady state error is 0 and what is the input, then you have to give answer unit step input. So like that you have to remember from this table, like that question you can make and prepare. All right, now the next one is for a second order system, if damping ratio is less than 1, then the system is okay. For damping ratio, they are asking. So damping ratio is what? First, if we talk about our damping ratio, generally it is in control system. So damping ratio is a dimension dimensionless transient response. Okay, it is dimensionless transient response. Okay, transient dimensionless transient response. Okay, and if you see the formula for this damping ratio, basically we will represent with this one, zeta. Zeta is equal to c by cc. Okay, c by cc, where this c is what? Actual damping, actual actual damping coefficient, actual damping coefficient, and this cc is what? Critical damping coefficient. All right, So now we have some condition like this damping ratio is equal to 0. Suppose this damping ratio is equal to 0, then system is system is undamped. Okay, system is undamped, and when this zeta is equal to 1, then system is critical. Okay, system is called critical. When this zeta is less than 1, then system is called underdamped. Underdamped. Okay, so we have undamped and we have underdamped. Undamped when it is 0, underdamped when it is less than 1. Okay, and when it is greater than 1, then system is called overdamped. Okay, system is called overdamped. So these are the some condition for zeta you have to remember. Here they have asked question for second order system. If the damping ratio is less than 1, less than 1 means this one. So system is called underdamped. Underdamped means option B is your right answer. Okay. Okay, this one only you need to remember here. Now the next one. In the energy level diagram, what is the separation between conduction band and balance band? Okay, they have asked question for energy band diagram. So we have energy band diagram here like this. Okay, this is your energy band diagram. So this we call conduction band and this we call balance band, and they are asking the separation between conduction band and balance band is what? So this is called forbidden energy gap. Forbidden energy gap. This is called forbidden energy gap. Okay, this is called forbidden energy gap, and this is denoted with EG. Okay, this is denoted by EG. All right, when some condition you have to remember for conductor, insulator and semiconductor. All right, so for conductor, this EG means forbidden energy gap is approx you can say 0. Okay, and for insulator, this Eg is greater than 3 electron volt, and for semiconductor this Eg is less than 3 electron volt. Okay, just remember these points. So here they have asked about separation between conduction band and balance band. So it is forbidden energy gap. Option A is your right answer. All right. Gray code of gray code for 1101 is given by. So we have binary number 1101. This is your binary, and they are asking convert this one in a gray form. Okay, gray form. So for binary to gray or gray to binary, you have to convert. For that, you need to remember truth table of XOR operation. Okay, XOR operation. So what is XOR operation? 0 0 0 1 1 0 1 1. So in XOR operation, when both are 0, then this is 0. When any one is high, then it will high, and both are 0, both are 1. So 0. So whenever odd number is high is there, then in XOR operation output will be 1. All right. Now for conversion of binary to gray. Now, how you are going to convert binary to gray? We have binary number 1 1 0 1. Okay, this we need to convert in a gray. So this first bit we will call in a digital MSB. Okay, most significant bit. So this you need to write as it is. Okay, 1 it is, so 1 only. Now here you need to apply XOR operation between these two. So 1 XOR 1. 1 XOR 1 is what? 0. All right. Then you need to apply XOR operation here, 1 and 0. So 1 and 0 is what? 1. So this is 1. Now 0 XOR 1. So 0 XOR 1 is what? 1. So this is 1. So this is what? This is gray to binary conversion. Okay. Sorry, binary to gray conversion. So this is the binary number. This is the binary. We got gray 1011 option B. Sometime they will ask question gray to binary. Okay, gray to binary. How you are going to convert from gray to binary? Suppose same question, if they will give 1011, it is in gray. Just now we have found this one, it is gray. So 1011. Now we need to find binary. So it will come this wala 1101. Okay. So here this MSB you need to write as it is, so it is 1. Now you need to put XOR operation in between these two. Okay, 1 0. So 1 0 is what? 1 0 is 1, so it will be 1. Now again you need to apply XOR operation in between 2. So 1 1, 1 1 is what? 0, so it is 0. Again this XOR operation you need to apply from here to here, so 0 and 1. 0 and 1 is what? 1. So now you can see we got the binary number 1101 as we have here it is appeared. So like that you need to do binary to gray and gray to binary. All right. The 2's complement of the binary number we have 0 0 1 1 1 1 0 0. This is binary. We need to find the 2's complement. For 2's complement, first we need to convert in a 1's complement. So for 1's complement, we need to just complement the complement of the number. Like this is 0, so it will be 1 0 1 1 0 0 0 0 1 1. This is what? This is 1's complement. Okay, this is 1's complement. Now for 2's complement, we need to add 1. Okay, we need to add 1. So 1 1 10. So this is 0 and 1 it will go carry. All right. So it will go carry. So 1 1 again it is 0. Then 1 we have carry. Then rest you need to write like this. So this is your what? 2's complement. 2's complement. All right. And this is matching with your option A. So option A is your right answer. Okay. A super heterodyne receiver with a intermediate frequency of 450 kilohertz is tuned to signal at 110 kilohertz. The image frequency is, we need to find the image frequency. So we have what we have given, we have given intermediate frequency. Okay, you can say Fi, you can write Fi, it is intermediate frequency, or it is given 450 kilohertz. All right, and we have tuned frequency. Tuned frequency we will write Fs, so it will be 1100 kilohertz we have. All right, these things are given. We need to find image frequency. Image frequency means Fsi. This is what? Image frequency. So formula is there. We have tuned frequency plus 2 intermediate frequency I F I F. Okay. So image frequency is equal to what? Image frequency is equal to Fs, that is your tuned frequency, plus twice of intermediate frequency. We have all the value. This is 450 and this is 1100. Okay. 2 into 1100. So it will be so here it will come. Sorry, something we have done wrong here. Just a second. Value we have written wrong. So the value is what? For Fs we have 1100 and twice of 450. This is the right like value. So 1100 plus 2 into 450 means 900 kilohertz. Now this will be come how much? 200. Sorry, 2000 kilohertz. So from this option D is your right answer. Like that you need to calculate image frequency. Okay. Now the next one, for an AM signal, amplitude modulation signal, the bandwidth is 6 kilohertz and the highest frequency component present is 600 kilohertz. The carrier frequency used for the AM signal. We need to find the carrier frequency. We have here, they have denoted frequency means highest frequency component. Highest frequency component. First they have given bandwidth. Bandwidth we have 6 kilohertz. All right. And we have highest frequency component, that is upper sideband. In upper sideband it is 600 kilohertz it is given. All right. Bandwidth, if you see the bandwidth formula for AM signal, so bandwidth is equal to what? Bandwidth is equal to twice of FM. This is bandwidth formula for AM signal. Okay. So from here we can find bandwidth, we have 6 kilohertz, this is 2 and this is FM. So 6 by 2 is equal to FM, and FM equal to, you can write 3 kilohertz. So here we got FM equal to 3 kilohertz, and USB upper sideband is equal to what? Upper sideband is equal to FC plus FM, that is your highest component, highest frequency component. So FC plus FM, it is given 600, and this FC we need to find, that is carrier frequency. FM just now we have calculated here 3 kilohertz, so this is 3. Now 600 minus 3 is equal to FC, and 600 minus 3 is what? 597 kilohertz. So we got the FC, that is your carrier frequency is what? 597. Option C is your right answer. All right. Now the next one. Next one is what? Who among the following is not a type of addressing mode in 8085 microprocessor? Okay. So total we have 5 types of addressing mode. 5 types of addressing mode in 8085 microprocessor. Okay. First one is your direct addressing mode. Direct addressing mode. Okay. Then second one is your register addressing mode. Third one is your implicit addressing mode. Okay. Implicit addressing mode. Fourth one is your indirect register indirect addressing mode, and last one is your immediate addressing mode. Okay, immediate addressing mode. So direct addressing mode, register addressing mode, implicit addressing mode, register indirect addressing mode, and immediate addressing mode. These are the 5 type of addressing mode is there in 8085. So this relative addressing mode is there. So this is not related to 8085, this is related to 8086 microprocessor. Okay. In 8086 microprocessor, it is the type of addressing mode for 8086 microprocessor. Apart from that, all threes are related to 8085. Okay. So just remember this 5 type of addressing mode. Okay. Now the next one, the correct instruction execution sequence is, so in a microprocessor, whenever instruction is given to a microprocessor, so it is that opcode is going to, first it will fetch, okay, in an instruction cycle, first it will fetch the opcode from the storage element or memory, then it will decode that one, and after decoding it will execute. Okay, after decoding it will execute. So this is the instruction cycle in a microprocessor. So fetch, decode, execution, this is the process or step, you can say. All right. The doping material for n-type semiconductor is what? So for doping material they are asking for n-type semiconductor. If you talk about semiconductor, Semiconductor, basically we have two types. Okay, first we called intrinsic semiconductor or pure semiconductor. Okay, and the another one is extrinsic semiconductor. Okay, so and further, this intrinsic semiconductor is divided into two types, that is your n type semiconductor, and another one is your p type semiconductor. Okay, so what happened, doping means what, here they have this asked for doping. So doping is the process adding of impurity atoms, adding of impurity atoms in pure semiconductor or intrinsic semiconductor, you can say. Okay, pure semiconductor. So the thing is, when when pentavalent when pentavalent atom is doping with pure semiconductor or intrinsic semiconductor, pure semiconductor, then it will called n type semiconductor. Okay, and when trivalent trivalent atom is added with pure semiconductor or doping with pure semiconductor or doping with intrinsic semiconductor, then it will called p type semiconductor. Okay, so here they have asked for n type semiconductor. So n type is pentavalent and p type is trivalent. Okay, pentavalent means what? Pentavalent means what? In for an atom, if outermost electron having 5 electron, if in an outermost cell having 5 electron, then it will be pentavalent. And for trivalent, in outermost cell it will be 3 electron, then it will called trivalent. Okay, so from here pentavalent is the right answer. Dash is the maximum reverse voltage that can be applied to the PN junction dash to the junction. Okay, maximum reverse voltage. So whenever maximum reverse voltage is there, so maximum reverse voltage is what? Maximum voltage reverse is what? Like PIV is there, we have PIV, that we call peak inverse voltage. So PIV is what? PIV means it has peak inverse voltage, means it has maximum reverse voltage, maximum reverse voltage or maximum value of voltage that can be withstand for PN junction diode without damaging. Okay, this is the maximum value of the reverse voltage that will be withstand with PN junction diode without damaging that diode. All right, and for so here you can say same definition it is written. PIV, that is peak inverse voltage, is the maximum reverse voltage that can be applied to the PN junction without damage the junction. Okay, so here option A is right answer. And from this PIV you just need to remember, for PIV, half wave rectifier, we have half wave rectifier, full wave rectifier. Further, full wave rectifier is divided into two types: center tapped rectifier and bridge rectifier. So for half wave rectifier, this PIV is equal to VM, that is maximum voltage. Okay, and center tapped rectifier, this PIV is equal to 2 VM, and bridge rectifier, this PIV is equal to VM. Just remember this 3 point. From here sometime they will ask question, what is the PIV for bridge rectifier? Then you need to give answer VM. Okay, so then the last one is what? Dynamic RAM, that is DRAM, is slower than static RAM, that is SRAM, because. So why DRAM is slower than SRAM? Okay, if we talk about memory, so memory we have two types. First one is your RAM and another one is your ROM. Okay, RAM means what? Random access memory, and ROM means what? Read only memory. RAM is what? Volatile memory, and ROM is non volatile memory. Okay, RAM is volatile memory, ROM is non volatile memory. Further, this RAM is divided into SRAM and DRAM. Okay, SRAM, static random access memory, and dynamic random access memory. So this SRAM and DRAM, they have asked for this one. So SRAM, if we talked about SRAM, so SRAM uses flip-flops for storing the elements. Okay, it uses flip-flop, and DRAM uses capacitor. Okay, DRAM uses capacitor to store the element. So as it is using flip-flop, so refreshing not required. Okay, refreshing not required. Okay, and here as it is using capacitor, so here refreshing is needed. Refreshing required. Okay, this, because here refreshing is required, that's why it is slower, and here refreshing is not required, that's why this SRAM is faster than DRAM. Okay, so from here you need to write C option C. DRAM required refreshing, that's why it is slower than SRAM. Okay, you need to practice more from this study guide of like here in this study guide you are going to get ebook which is available in the Play Store right now, the Mann Maker app. It is there, all the study material is there for BL Probationary Engineer. Complete study material is there. In that you will get one ebook. There you will get subject wise short notes and subject wise MCQ with details explanation of answer. Then 500 important question you will get with answer and explanation. Then 150 non-tech question you will get, that in your exam non-tech also it will come. So 150 non-tech question will come. Then previous year paper it is available in that app also, and full mock test series is also there. You have to attempt test series for this exam also. So all the things are available in this app. Just go and check that one, and you can take. If you have any kind of doubt, you can drop a message here, and you will just. Other thing is you need to prepare from here the study material and all over the things, and you need to be focused in the YouTube also. In YouTube, like that only I will take classes. I will upload the video in this playlist only. Just save this playlist. Here I will upload the all the classes, whatever I will take important question or short notes classes, whatever I will take, I will upload in this playlist. And for preparation you need to take this one, and you have to prepare. Here you will get complete the things, short notes and question and all the things. So that much for today. Okay, we'll meet in the next class. Thank you for today. If you like the video, just hit like on the button. Kindly share with your friends. And if you're not subscribed my channel till now, just subscribe the channel and press the bell icon. Okay, that's all for today. Thank you.